Okay, so if we want to find all 6 trig functions, we'll go ahead and make the hexagon identities graphic organizer. And remember tangent, and then we use the quotient identity to go around. So tangent starts on the left, then that's equal to sine divided by cosine. And then we can fill in the reciprocal identities on the diagonals. So secant is the reciprocal of cosine, cosecant is the reciprocal of sine, and then the reciprocal of tangent is cotangent. Okay, so let's go ahead, make some room up here, and then with a different color, we'll fill in our given information. So the cosine is -1/5. And the reciprocal then, secant, would be the reciprocal of -1/5, which is -5. Okay. Now the tangent we know is positive, but we don't know its value. So in order to find these others, we're going to need to use a Pythagorean identity. And since I don't want to deal with that fraction, I'll go ahead and use this Pythagorean identity here where the tangent squared, so tangent squared of x plus 1 is equal to the secant squared of x. So if we substitute in what we know, we've got tangent squared x equals, and the secant is -5. And then we're going to square that, and we'll go ahead and subtract this 1 to the other side. And then we'll square root both sides to get tangent by itself. So the tangent of x is going to be -5 times -5 is 25, minus 1 is 24. So that's a square root of 24. And we'll simplify that square root then by breaking it down into its prime factors. So 24 is 2 times 12, and then 12 is 2 times 6. 6 is 2 times 3. So we've got a pair of 2's and then a 2 and a 3. So the tangent of x, when we reduce that radical, is going to be positive because it tells us the tangent is positive in this problem. And then we can pull out that 2 and leave the square root of 6. Okay, so that answer then is 2 square root of 6 here for my tangent using the Pythagorean identity. Okay, so we've got that piece. Now we can use another identity in order to find, see if I can clean that up there, 2 square root of 6. We can use another identity now to find the sine. That product identity lets us make a hinge. So if sine is my hinge that I'm trying to find, I go out to the 2 vertices to the left and right and multiply them with that product. So that means that the sine of x is equal to the tangent of x times the cosine of x. And when I put in what I know, 2 square root of 6 for the tangent of x, and that's times -1 over 5 for cosine, and then we can multiply those fractions straight across, -2 square root of 6 in the numerator and a 5 in the denominator. So the sine is equal to -2 square root of 6 over 5. Okay, then to find the cosecant, we could do the reciprocal of the sine. So since sine of x in the denominator is going to be equal to the cosecant of x, we can take the reciprocal then of the sine. So that's 5 divided by -2 square root of 6. And we'll multiply the top and bottom by square root of 6 over square root of 6 to rationalize that denominator. We'll have a -5 root 6 divided by 2 times 6 is 12. So -5 square root of 6 over 12 for the cosecant. And last but not least, We still need to find the cotangent, and we have some choices, right? We could use the product identity here with cosine times cosecant. We could use the quotient identity by taking cosine divided by sine, or cosecant divided by secant. I'm going to, for this one, just go ahead and use that reciprocal identity by getting the reciprocal of the tangent. So when I rationalize that denominator, then I have square root of 6 over 12. And that would be the cotangent. Now we've evaluated all 6 of the trig ratios for the angle whose cosine is -1/5. Hope that helps.